Okay, last lecture we have proved the first theorem of calculus, that if C is a cluster point of A, then it is surrounded by infinitely many points. No matter what delta you choose, you will end up having infinitely many points in the neighborhood of C. That is what we have understood. And we have written. Okay, so we are supposed to do an exercise today, and that is we need to understand and write the definition of limit without looking into the definition that we have already written. Whether we have understood, are we missing some important elements of that definition or not? So we are going to check it for next 10 minutes. So I am pausing the video. Definition. लिहून घ्या. Let A be subset of R. And let f comma g be functions defined from A to R. We define sum f plus g on the difference f minus g, the product f into g, A to R to be functions given by f plus g of x is defined as f of x plus g of x. F minus g of x is defined as f of x minus g of x. F into g of x is defined as f of x into g of x. Similarly, if h of x is not equal to 0 for x belonging to A, we define quotient f upon h to be given by f upon h function of x is defined as f of x upon h of x for all x belonging to A. This is definition. So it has to be as it must be if and only if, and is assumed to be true. Summation is simple. Summation function is sum of functions. Difference function is difference of functions. Product function is product of functions. And quotient function is ratio of functions, provided the ratio is the denominator of the ratio is not equal to 0. झालं लिहून सगळ्यांचं? Very good. One thing which I want to mention here in the proof that we have written last lecture, that there are infinitely many points in the vicinity, in the neighborhood of a cluster point. One thing which we have assumed to be true and need to be mentioned in that proof is amongst the finitely many positive real numbers. So just you make a note of this in your notebook immediately after that proof. The finitely many positive real numbers, there exists its minimum. When we said we will consider minimum of delta, we are assuming this. And it is unique and it's positive. It's unique and positive. This is something which is true, but is being assumed in that proof, delta 1, delta 2. It will be mentioned there. Okay? Okay. So now the job that we need to do now is basically having defined the algebra of limits to check what happens to the limits. So first thing that we are going to prove, theorem, A B subset of R, let F be defined from A to R, let C be cluster point A, let C be the cluster point of A, let L1 and L2 belong to R if one limit x tends to C, F1, sorry, if limit x tends to C, okay, now this is not addition, but maybe theorem before that. F of x, if limit x tends to C, f of x is equal to L1, limit x tends to C, f of x is L2, then what should be the result of this theorem? And then we go back to algebra of, so this is the first limit related identity that we are going to prove, that if as x tends to C, f of x, first statement is this limit is L1, second statement is this limit is L2, then what should happen? That is the first theorem. So can you tell me what should happen here? Third, what should be the third thing that we should write?
Sir, L1 plus L2.
L1 plus L2. We are not considering addition right now here. Addition theorem, the whatever definitions which we have written will be proving them and finding out their limits later on after this. This is something which we need to understand and do maybe before doing algebra of limits. That now instead of drawing y on vertical axis like this and x on horizontal line like this, now it is fashionable because it takes little more space. It is convenient to draw two horizontal lines. Now suppose you are here, this is your C and it is a hollow circle C. So your X is moving towards C from this side as well as from this side. Okay, so this is the picture of domain, picture of codomain. So what happens with the codomain? If limit f of x as x tends to c, suppose this limit is L1. Okay, so images under F near C will go to images near L1. That is what first statement says. And second statement says the limit is L2 also. Right? So that is what is the picture. So the RHS, the third part of this theorem must be, if we are saying, if we go back to the definition of our limit, then the third part of this theorem must be L1 is equal to L2. That is the only thing we should do with us. We cannot afford to have some portion of neighborhood of C go to L1 and some other portion of neighborhood of C go to L2 and L1 and L2 are distinct. We will not be able to afford that. So you think about how do you write the proof of this? Because this is the first calculus proof, I would like to show you how it has to be done. Basically, intuitively, this cannot happen. Why this cannot happen intuitively? Because in the definition of function itself, we have said that we cannot release two arrows from a point in domain. It is as simple as that. And that exactly is happening here. We are not changing the definitions of the function, etc., what we have written earlier. We are keeping them same. Now, only problem was about the behavior of that function near C, which was ambiguity earlier. The definition of limit is trying to remove that ambiguity. The definition of limit is saying that don't look at C. Don't look at what happens at C. And if the function is well behaved, it is enough to look at the neighboring points of C. How much neighboring? Delta neighborhood. How much is delta? You find out depending upon the epsilon which is given to you. Okay. So that is the approach that we are taking. We are not interested in figuring out what happens at C. However, whatever happens at C, if the point C is in the domain, and if the function is well behaved, whatever happens in the neighborhood of C is something similar. It is going to be similar, then only we are going to say that limit exists. So if we are saying that limit exists and it is equal to L1, and if we are saying that function is good and limit exists and it is also equal to L2, of course L1 and L2 must be same. Otherwise, for all intuitive reasons, it defeats the definition of function itself. If some points in the neighborhood of C go to L1, if some points in the neighborhood of C go to L2, then we will not be able to say that as you go near C, you will arrive at some limit L1 or L2. In that case, that function itself is not going to follow the definition of functions. Therefore, intuitively, this is correct. L1 must be equal to L2. It is a unique limit that you have. You cannot end up having two different limits. Then in that case, we will not say limit exists and it is equal to L1. Do you understand the difference? and therefore that point need to be highlighted. Even if you can write this is contradiction to definition of function, but that is not going to be considered as complete correct proof unless and until we show some contradiction which is very obvious and known to us. Therefore, proof. Now, if this point is L1 and if this point is L2, if possible, let us start, because we want to show L1 is equal to L2, and the only way to do that is by contradiction. If possible, let L1 is not equal to L2. Without loss of generality, L1 is less than L2. Okay. So what is happening is L1 is less than L2, and now epsilon will be given to us. What does this function, what does statement number 1 mean? Let me write down here. Statement number 1 implies for every epsilon greater than 0, there exists, let me call it as delta 1 greater than 0, such that for every x belonging to deleted delta 1 neighborhood of C intersection A, we have f of x minus L1 is less than epsilon. Okay, so this is what is the meaning of statement number 1. This is what is the meaning of statement number 1. So now it is going to happen for every epsilon. So if we want to finally show the contradiction, we should wisely choose the given epsilon such that the contradiction that eventually we will get is going to be absolutely clear. Now, if you choose the epsilon so big that for L1 it also includes L2, and for L2 you choose epsilon such that it also includes L1, then showing contradiction will be problem. Intuitively we understand this cannot happen. Therefore, in proof we have to show the contradiction. Therefore, we have to choose epsilon, one epsilon. It is contradiction method of proving it. Therefore, if we show the contradiction by choosing one epsilon, it is good enough, because the first statement says for every epsilon. That is the important part of this definition. One implies for every epsilon, and if we come up with one epsilon which will contradict the statement, then that is good enough. Therefore, there could be many epsilons which can be considered, but I will consider the epsilon, the distance between these two is made 3 equal parts, so there is nothing common between them. So consider equal to L2 minus L1 upon 3. Is this quantity going to be greater than 0? Yes, epsilon is greater than 0. Now let me write down 1. What does one statement 1 imply? Exactly this thing I am going to write it again, but here the epsilon is going to be this. Okay, 1 implies there exists delta 1 which is greater than 0 such that for every x belonging to deleted delta 1 neighborhood of C intersection A, we have of x minus L1 is less than L2 minus L1 by 3. This is what is our epsilon. Okay, let us call this statement 4. I can write down what does 2 imply. There exists delta 2 greater than 0 such that for every x belonging to deleted delta 2 neighborhood of C intersection A, we have f of x minus L2 is less than L2 minus L1 upon 3. This is statement number 5. Okay, up to this point, is there any doubt? We have wisely chosen. You can choose this L2 minus L1 by 4. Even if you can choose L2 minus L1 by 2 also is fine. But we have some points between these two epsilons and we are going to contradict for one epsilon. Therefore, our theorem is going to be. So now I have got one delta 1 and another delta. Statement 1 gives me one delta, statement 2 gives me another delta. I do not know which delta is bigger, which delta is smaller. Therefore, the obvious step that I will perform after this is choose delta is equal to minimum of delta 1 comma delta. So, of course, if delta 1 is smaller than delta 2, so all the points in the delta 1 neighborhood of C will be in the delta 2 neighborhood of C. So that will be intersection is going to be common between them. Therefore, we choose delta which is minimum of delta 1 comma delta 2. So if for this delta, what will statement number 4 and 5 do? Or if we consider as C is a cluster point, of A, exists X naught belonging to A deleted delta neighborhood of C, there exists X naught belonging to A, that there exists X naught belonging to A, actually intersection deleted delta neighborhood of C. What will this X naught do? There will be X naught in the delta neighborhood of C intersection A. 4 and 5 will be true for that X naught. There will be values of X. Basically, suppose delta 1 is smaller than delta 2. So all the points in the delta 1 neighborhood, which eventually we will call as delta neighborhood, all the points in the deleted delta 1 neighborhood of C intersection A, 4 will be true and 5 also will be true. So 4 and 5 will be true. Okay, so this is the preparation that we have done and now we are supposed to show the contradiction. So consider 3 times epsilon, which is equal to absolute value of L2 minus L1 or L1 minus L2 minus L1, because our epsilon is L2 minus L1 by 3 and it's a positive value. Okay, now look at the final steps that we perform. That is equal to absolute value of L2 minus f of x minus L1 plus f of x, which is equal to absolute value of L2 minus f of x, L2 minus f of x, किंवा आपण काय करूया उलट सुलट करूया म्हणजे आपल्याला आपल्या डेफिनेशन प्रमाणे रिप्लेस करता येईल. This is equal to absolute value of f of x minus L1 f of x minus आणि अजून काय करूया प्लस L2 minus f of x. Okay, so now I want to have absolute values here. So absolute value of x1 plus absolute value of x2 is what of absolute value of x1 plus x2. This is triangle inequality that we have studied many times. In triangle inequality, we have proved this. In complex numbers, we have proved something like this. Sum of the two sides is always greater than the third. So the inequality is going to be like this. Do you agree with me? If I want to split x1 and x2 by their absolute value signs, then this quantity is going to be greater than or equal to this quantity. So now I have this quantity with me, which is going to be less than or equal to absolute value of f of x minus L1 plus absolute value of, now absolute value of L2 minus f of x and absolute value of f of x minus L2 is one and the same. See whether you understand each and every step of this proof or not. Now here I am using by triangle inequality. By okay, but f of x minus L1 is less than epsilon. So now it is strict inequality, less than epsilon, and this is also strictly less than epsilon. Yes or no? What we get in the end is this implies 3 epsilon is strictly less than 2 epsilon and epsilon is greater than 0. Contradiction. Hence, theorem proved. Now you can ask me questions. Which particular step you have not understood?
सर
Yes.
सर ते मिनिमम डेल्टा वन डेल्टा टू क्या लागला आपल्याला
काय नाही ऐकायला आलं.
सर ती डेल्टा इक्वल टू मिनिमम ऑफ डेल्टा वन आणि डेल्टा टू स्टेप का गॅप करायला लागले आपल्याला
कारण काय असतं की सपोज दिस इज अ गुड क्वेश्चन. Suppose your C is sitting here and 1 implies delta 1. So 1 gives you suppose this neighborhood. So this is called say delta 1 neighborhood. 2 gives you delta 2 neighborhood, which is say for a without Losser generally suppose delta 2 is greater than this. Okay. Now you are going to write down something which is for these x. Now you are interested in these x because these values of x are satisfying 1 as well as 2. However, these values of x are satisfying only 2 and not 1. And therefore, if we want to have contradiction, we might as well take those points x which satisfy both 1 and 2. And therefore, we have to choose minimum amongst these two. Therefore, we are very, very safe. That is why this step will appear there many times in different proofs. You have delta 1, delta 2, delta 3, delta 4, delta 5. And if you choose minimum of them, then all those 5 statements are going to be true, or all the x between the delta neighborhood of C will be following all the 5 requirements that you have given. That is why choosing minimum distance, minimum delta is very important because you are sure about them. You are sure about all those points that they are well behaved. They are behaved for condition number 1. They are well behaved for condition number 2 also. However, the points sitting here you cannot guarantee whether they will be well behaved for the first statement or not. That is why we have to choose delta minimum.
तर मध्ये खालच्या ज्या सगळ्या स्टेप्स आहेत एफ ऑफ एक्स आणि L1 आणि L2 च्या, त्याच्यामध्ये ऍक्च्युली तो एफ ऑफ एक्स नॉट आहे का?
नाही कळत आहे. काहीतरी प्रॉब्लेम आहे, सलग ऐकायला येत नाही व्यवस्थित.
सर ते क्लस्टर पॉइंट ऑफ ए जे आपण ते लिहिलंय फॉर एव्हरी देयर एक्झिस्ट एक्स नॉट, तर खालच्या सगळ्या स्टेप्स मध्ये एक्स मध्ये एक्स नॉट आहे का?
हा, एक सॅम्पल पॉइंट एक्स नॉट असा जर घेतला त्या डेल्टा आणि बलून मधला, तर तो 3 आणि 4 आणि 5 ट्रू काय त्याच्यासाठी ट्रू आहेत. आणि असे इन्फायनाइटली मेनी पॉइंट्स आहेत. एक एक्स नॉट असेल तर तो निश्चित वेल बिहेव्ड आहे. दॅट इज व्हॉट वी हॅव मेन्शन्ड. That sample point x naught in the delta neighborhood of C is very well behaved. That is what is the meaning of that statement. Any other question? Have you understood this? I mean, intuitively, it is not following the definition of function. That is the proof. But if we want to show it in black and white, then 3 epsilon cannot be less than 2 epsilon, and we brought it finally. And the most important step is this, which is triangle inequality. Now you see in this particular proof, we have extensively used the definition of limit. Unless we have clear-cut understanding of definition of limit, we will not be able to make use of that. And therefore, you go through each and every step and follow it. Here we have written epsilon is equal to A2 minus L1 by 3. So this is actually, here it is actually epsilon. Here it is epsilon. So maybe instead of writing L2 minus L3 by 3 there, we can write epsilon here. We can write epsilon here because epsilon and that is same. And then it is very easy to substitute. This is epsilon substitution because this quantity is strictly less than epsilon. This quantity is strictly less than epsilon. Therefore, summation of these two quantities is definitely going to be. So epsilon plus epsilon becomes 2 epsilon, and we started with 3 epsilon, and hence we made the contradiction. And therefore, if limit exists, this is uniqueness of limit. Uniqueness of limit. If limit exists, it is unique. That is what is this theorem all about. Okay, good. लिहून घ्या सगळं व्यवस्थित. Okay, before getting into algebra of limits, let us work on finding out epsilon delta. How do we do the calculations for finding out delta given epsilon or something like that? We will try to learn that and be comfortable with epsilon and delta. Okay, so now suppose if I give you this problem question. F is defined from R to R. F of x is equal to 3x plus 5. Find the limit x tends to C, f of x. Justify your answer. Okay, so this is the exercise given to you. Now, is 3x plus 5 good function or a bad function? It is very, very good function. Straight line. Does it have any points which create ambiguity, undepth? undefinedness, etc. No, it is very nice function. No problem. Can we really find a array? Not x is equal to c, let x is equal to b2. If limit definitions were not there, calculus was not there, can we find out the value of the function at x is equal to 2? Yeah, 6 into 2, 11. 11 is going to be the value before calculus also, and now we are going to say that yes, 11 is the value after calculus also, but then we have a responsibility of showing why it is 11 after calculus. That is the meaning of this justify your answer. I give you a couple of minutes for writing your justification, because limit is 11. We know, all of us know that the limit is 11. I give you time to think and write the justification. Okay, now let me show you how to go about it. Few of you have attempted it and it is more or less correct. We want to show that limit x tends to 2, 3x plus 5 is equal to 11. This is what we want to show. Now, what does this mean? This means if we go near 2, if we go near 2 in the delta neighborhood of 2, if we go, then we will be in the epsilon neighborhood. If we are in the delta neighborhood of 2, we will be in the epsilon neighborhood of, no matter what epsilon is given to you. For every epsilon that is given to you. So if for epsilon that is given to you, you want to remain in the vicinity of 11, epsilon vicinity of 11, what should be the value of delta, so that you should stay, all your x should be in that delta neighborhood of 2, finding that delta and showing that if you stay within that delta, you will always be within the epsilon neighborhood of 11 is justifying your answer. So now it is easy, oral, but we need to do some kind of calculations which I will show you a little later. But presently, if I want to stay in the epsilon neighborhood of 11, okay, what should be the delta? So now here, for any x, what do we mean by delta? Delta means delta is equal to absolute value of x minus 2. You choose any x, its distance, I mean delta is greater than, delta is going to be greater than any point in the neighborhood of 2. Greater than. Or maybe let me write down it in opposite direction. X minus 2 absolute value is going to be less than delta. That means all those x which are in the delta neighborhood of 2. Okay. And what is the meaning of epsilon neighborhood of 11? It is absolute value of f of x minus 11 should be less than epsilon. Should be less than epsilon. That is the meaning of epsilon neighborhood of 11. This is delta neighborhood of 2. Okay. Okay. And now the calculations, if you do, I mean, you start with this, you want to show this. So rough calculations are going to be starting with this point. This is what we want to show. What does this mean? This means absolute value of 3x plus 3x plus 5 minus 11 should be less than epsilon. This implies 3x minus 6 should be less than epsilon. This implies 3 into x minus 2 should be less than epsilon. This implies 3 times absolute value of x minus 2 should be less. epsilon. Now absolute value of x minus 2 is what your delta is, and therefore absolute value of x minus 2 should be less than epsilon by 3. So this is what we got from our rough work. Okay, and hence proof of this, how will we write the proof? Justification, that means proof. Let first statement of any proof in calculus is let epsilon greater than 0 be given. Choose delta is equal to epsilon by 3. By these calculations we know that choose delta is equal to epsilon by 3. Note x is equal to 2 is a cluster point of R. R is our domain of definition of F. Let x belong to deleted epsilon by 3 neighborhood of 2 intersection R. For this x, consider absolute value of f of x minus 11, and then show the same calculation done in this proof, which is equal to absolute value of 3x plus 5 minus 11, which is equal to absolute value of 3 into x minus 2, which is equal to 3 into absolute value of x minus 2, which is less than 3 times epsilon by 3, which is equal to epsilon. Hence, by definition, limit f of x, which is 3x, as x tends to 2 is equal to 11. 2. Let check whether you have understood every step or not, else ask me difficulty.
Excuse me, sir.
Yes.
Sir, in this, sir, how can we choose delta? Sir, because in the definition we have some specific delta, right?
No, in the
For
definition,
all x, there exists delta.
yeah, for all epsilon there exists delta. Yes.
Yes, sir.
So if we find out delta in terms of epsilon successfully, and then if it is working for that value of delta, which is in terms of epsilon, we have not taken epsilon is equal to 1 or epsilon is equal to 5. We are taking epsilon is equal to epsilon, and we are trying to find out delta in terms of epsilon. So if you say epsilon is equal to 1, then delta will be equal to 1 by 3. If you say epsilon is equal to 2, then delta will be 2 by 3. And it works. So for every epsilon it will work. We can find out the delta. There exists delta. It will depend on epsilon. Delta will be dependent on epsilon, and therefore we are getting, in this example, we are getting delta is equal to epsilon by 3.
Okay, sir.
Okay. Now, epsilon delta proofs or solving problems related to epsilon delta is epsilon is given to you, you find out the delta. And it might not be always such simple algebraic expressions. Those are functions. There will be complicated functions for which you also should be able to estimate what delta should be. So let me give you second question now. Question number 2. Limit x tends to x square plus 6 is equal to 9 is 15. Prove. Now, it is not as simple as a straight line that we have done, but because of quadratic, we end up having some additional factors. So let us see how to deal with that as far as finding out the epsilon is concerned. Okay. Suppose we want to do calculations, rough calculations, then how will they go about it? I want to eventually show, because this limit is true, but now it is a question of writing epsilon and delta proof for showing that yes, this limit is correct, and therefore consider f of x minus 15 we want it to be less than epsilon. Epsilon is given to us. This is x square plus 6 minus 15 should be less than epsilon. That is what we want. That means it is x minus 9 should be less than epsilon. That means it is x minus 3 into x plus 3 should be less than epsilon. Now you will be surprised to know that this x minus 3 and as x tends to, so because it is product we don't have splitting, then x minus 3 into x plus 3 should be less than epsilon. And now this is what we are interested in. We are interested in this should be less than what, and it comes out to be epsilon by x plus 3 actually, and it is a part of, it is a function of x. The delta that we are trying to find out, if it is a function of x, then we are in trouble because it will change as per the value of x that you choose in the neighborhood of 3. We don't want that to happen. We want, if this is 3, where should we go? If this epsilon is given to you, where should we go? Epsilon 1 is given to you. If epsilon 2 is given to you, you should have calculations to say, oh, go here. Something like that. This is delta 1, this is delta 2. If epsilon 10 is given to you, you say, okay, you go here. This is epsilon 10. Something like that we need to have. And therefore, even if this is delta that we have found out, but then straight away epsilon that we get is a function of x, which is not acceptable, and therefore we have to estimate, because we are dealing with inequalities, we are not dealing with equalities, and therefore this step that we are going to follow now is going to be extremely important. Suppose if delta is equal to 1, suppose we take delta is equal to 1, what does this mean? This means absolute, or maybe this means x minus 3 is greater than minus 1 and is less than 1. Is that correct? That is the meaning of delta. You are in the one neighborhood of 3. That means this is the meaning of that. What does this mean? Now x is here.
1 आणि 4 असलं पाहिजे.
This is
1 आणि 4 असलं पाहिजे.
then x is
1 neighborhood of 3 म्हणजे.
बरोबर आहे मध्ये पाहिजे x. जर डेल्टा 1 असेल तर, अरे हो का नाही? राईट? नाही, काय झालेलं आहे? बरोबर. And now we want a number, we want to replace this x plus 3 by some number. Therefore, we consider 5 should be less than x plus 3 should be less than 7. Understand these steps, they are very, very important. I mean, we are not in the business of equality, we are dealing with inequality. And this quantity should be less than epsilon by x plus 3 we get, but x is a function of this delta becomes a function of x, which we don't want. And x, if delta is equal to 1, then x plus 3 is always going to be less than 7. And this x plus 3 is in the denominator, therefore we should choose the bigger number, biggest number rather. So if delta is 1, then x plus 3 is going to be 7 maximum, little less than 7. And therefore we conclude saying that x minus 3 should be less than epsilon by 7. That is our delta. Okay, new delta. By considering 1, we found out new delta as epsilon by 7. And therefore in proof, we will write, I mean, in proof, the first statement is let epsilon greater than 0 be given. Consider delta, which is minimum of 1 comma epsilon by 7. Suppose 1 is lesser than epsilon by 7, then 1 will survive. But if 1 is greater than epsilon by 7, then epsilon by 7 will survive. Do you understand? So we have taken support of this one. Now you will ask, if suppose delta is equal to 2, if we take here, then this denominator will change? Yes, it will change. But you should get denominator a number. It should not be a function of x. And delta should be either a constant, you tell delta is a constant, or you should tell delta is function of epsilon. You give me epsilon, I will tell you the delta. So minimum of 1 comma epsilon you have taken. And how will you finish this proof now eventually? Okay, writing this, consider. Choose delta, minimum of this, then you write one statement that then for every x belonging to deleted delta neighborhood of 3, we have absolute value of f of x minus 15 is equal to, you perform all these LHS steps and arrive up to this up to this, it is easy. This is equal to absolute value of x minus 3 into value of x plus 3. Is that right? And then you say that maximum value of x plus 3 is equal to 7. Therefore, therefore this absolute value of x minus 3 is epsilon by 7. This implies absolute value of f of x minus 15 is equal to epsilon by 7 into 7 is equal to absolute value of maximum. So absolute value of x plus 3 is going to be less than 7. Let us write that inequality here. Instead of writing maximum value, we write inequality. Note, absolute value of x plus 7 is going to be less than 7, which implies f of x minus 15 is equal to epsilon by 7 into 7 is equal to epsilon. Now here I should have it inequality. Okay. Now there will be a lot of ambiguity in this proof because you are being trained for equality so far. You would love to have this fellow as a representative of delta. But the problem is delta will depend, delta is going to be function of x if x is in the denominator or if x is involved in finding out the value of delta. And what we are doing here is, suppose this is C and this is your delta neighborhood, then for this x, this delta is going to be different value. For this x, delta is going to be different value. For this x, delta is going to be different value. It is going to be epsilon by x plus 3. Therefore, we don't want this in these calculations. We want delta means what bracket should I consider? And therefore, the estimation is important word. You estimate by taking delta is equal to 1. You find out whether suppose epsilon given is 7, then both of them are equal. Suppose epsilon is equal to 8. Then this one will survive as delta. If epsilon is 6, then 6 by 7 will survive as delta. And this proof will come through. Yes or no? So this is the most important step. Now, therefore, it is not necessary that student A's proof is something like this. Student B's proof can be different. Student C's proof can be different because this number that you are assuming right now is going to be different. Okay. Now you will say, sir, then what is this? I mean, this is not correct. This is not what we have been doing so far. But then you will consider the real life problem. Suppose this is a complicated function and customer has given you the epsilon, okay? And then you do not know how to calculate delta because it is very complicated function, complicated operation. The way we were not aware of finding out what was the variable which was changing the dimension of aluminum ring. It was a very complicated function, multivariable function. And therefore what do? You perform experiments. First, it is not that at 1 minute we arrived immediately. We observed the ring was in the mold for at least 10 minutes before we release it in the first trials and when the trials were successful. So, but keeping it in 10 minutes is not economical. Our rate of production will go low. Therefore, we have conducted trial for 5 minutes. Understood? So that time you can consider our delta we tried to be 5 minutes. But then we said, okay, 5 minutes is also working. It is enough for getting the dimensions. Then we said, okay, let us make it further down. We did it for 2 minutes. So by doing calculations, we were not arriving at those minutes because it is a complicated function. Maybe it is impossible to write the function. But we arrived at 2 minutes. And after that couple of trials, we said, okay, let us check half minute. And then we got distortion. We got dimension change. Then we said, okay, let us take 1 minute. And 1 minute was found out to be the optimum time as far as dimensions are concerned and as far as productivity is concerned. And therefore, we finalized 1 minute. Exactly similarly, we are just picking up some data. You may say, suppose, sir, if you would have taken data 1000, then what? Fair enough. We are writing academic proofs right now. We are writing proofs, we are learning to write proofs. So 1 and 1000 won't make any difference. So far you are choosing delta minimum of that quantity. I hope I have explained this. Are there any difficulties? शार्दुल काय झालं x स्क्वेअरला आणायचं नाही लेस देन आपल्याला डेल्टा शोधायचा आहे डेल्टा इज x - 3 x - 3 चं काय करू ते सांग x चं काय करायचं ते नाही विचारलेलं x - 3 चं काय करायचं ते विचारलंय you are supposed to find out delta and delta is absolute value of x minus 3. You are supposed to stay in the vicinity of 3. How much vicinity? Delta vicinity of 3. Therefore, x minus 3 is important. Given epsilon, you are supposed to find out x minus c. Okay, good. Hope you have understood it. Let us take another problem, little more complex.
Excuse me, sir.
Yes, bolo.
So can you explain the steps where we took minimum of delta? Like if epsilon is given, then the delta that we require, why will it be a minimum of 1 and epsilon by 7?
Yes, because now suppose epsilon is given which is equal to 6. Suppose. Okay. Then if epsilon given is equal to 6, then by our these calculations, our delta is coming out to be 6 by 7, which is, suppose this is your C, 6 by 7 is somewhere here, 6 upon 7, and we started with just delta is equal to 1, just like that, and that is falling outside 6 by 7. Therefore, which one you should choose? 6 by 7 you should choose, because these are the numbers, these are the values of x which will satisfy not only 1 but also 6 by 7. Therefore, minimum of 6 by 7 you should choose. Suppose epsilon given was 8, then this is your C, and your epsilon value comes out to be equal to 8 by 7, and your assumed delta was 1. Okay. So we should consider these values of x because they will satisfy delta 1 also, and they will satisfy 8 by 7 also. So depending upon delta, depending upon epsilon which is given to you, either you should choose 1 or you should choose epsilon by 7. Another example which I should give it to you is, if I want to be safe, suppose I am selecting all students in 7th standard, then okay, sometimes somebody who is getting 50% marks in our exam is also good, and he can be eligible candidate for Olympiad batch. But suppose I want to be safe, then I will say, okay, top 80%, top 20% students, those who have got more than 70% marks are selected for Olympiad batch. So if 50% is also acceptable to me for Olympiad batch, and if I set my target to 70%, then I am rest assured that these students are definitely going to be good. If student is getting more than 70% in our exam, he is bound to be good. So I am safe there. So how do I arrive at this number? It is based on my experience. So I decided, okay, if delta is 1, it is easy for me to adjust. So I start with delta is equal to 1 and check what happens to the function. And suppose somebody gives me epsilon, say it comes 6 or 8. Suppose epsilon is equal to 1. Then 1 is not going to survive. We will get 1 by 7 as delta. And it will work. Okay. So this is estimation. Estimation is very important word here. It is not exact finding out the numbers. It is the estimation that we are trying to do. And estimation is basically helping us to get out of this x plus 3 delta function of x. By estimation we can, and this is a safe estimation. You will not be in trouble by considering delta epsilon by 7. That is what this is explaining us. Epsilon by 7 is going to be safe delta. Either of them, I mean 1 or epsilon by 7. Whoever is the minimum is going to be safe delta for this function. Okay, we take one more example, couple of make this concept clear. Okay, so let us write down the next example. Example number 3. limit x tends to 2, x cube minus 4 upon x square plus 1. So these are not indeterminate form. They are simple functions. We could have also found out the answer for this function pre-calculus. Before defining the limits also we could find out. But then what we are doing right now is whatever were the answers before limit are the same as that of after limit. Okay. Before limit maybe you would have estimated the value of this function at x. After limit what we are trying to say that what is the value of this function in the vicinity of 2, and we say that it is going to be equal to 4 upon 5. Okay, I give you 4 or 5 minutes. Try to write down your proof now because you have experience of doing it for 2 problems before this. Let us do the calculations. Now, what do we want to do? We want to consider absolute value of x cube minus 4 upon x square plus 1 minus 4 upon 5. And we would like to figure out what happens to x minus 2. Because this is what is our delta. X minus 2 should be less than delta. So our watch will be on absolute value of x minus 2 because x is going towards 2. So this is our function. How much this is equal to 5x cube minus 20 minus 4x square minus 4 divided by 5 into x square plus 1. How much is this now? This is 5x cube minus 4x square minus 24 upon 5 upon x plus 1. Now you will be surprised to know that this is, even if it is cubic, x minus 2 is bound to be a factor of that. We will find out why it is so. But then numerator absolute value upon denominator absolute value. X minus 2 is supposed to be a factor. We will check what is the other factor. It is 5x square minus 10x square plus 6x creates plus 6x square minus 4x square. So minus 12x plus 12 is the other factor. And this is minus 24, correct. Okay, so this is equal to absolute value of x minus 2, which is what we wanted. And along with that, we have a function of ratio 5x square plus 6 plus 12 divided by 5 times x square plus 1. And now we are supposed to estimate this because we cannot afford to have this as function of x. We need a very, very safe number here. Okay, so now our last time procedure was to figure out let delta is equal to 1. Then minus 1 less than x less than delta. No, minus 1 less than x minus 2 minus 1 less than x minus 2 less than 1 implies 1 less than x less than 3, correct? So minimum value of x is 1, maximum value of x is 3 if delta is equal to 1. Okay. Now we want to estimate what this number is, and therefore if I want to estimate the denominator, I should take bigger number. That makes this estimation smaller, and I should take smaller number for estimating numerator. So as much this number as small that we can have is going to be safe, because you want to remain in the vicinity of C. In case of this problem, C is 2. By doing some calculations, if you arrive at delta, it should be very safe delta, and therefore it should be, this factor should be as small as what you can estimate. Okay, and therefore if for evaluating denominator 3, for evaluating numerator you use 1 and find out what that estimation is. Okay, so if we use 1 here in the numerator, we get 5 plus 6 plus 12 divided by, if we use 3 here, you know, 50. That is what is this number, when we use this inequality, right? And therefore this number happens to be 18. किती झाला तो नंबर, काय येतोय?
50 असेल ना डिनॉमिनेटर मध्ये.
50 sorry.
सर
थांबा जरा.
सर त्याचा तिकडे इनवर्स होणार, म्हणजे आपण ते ऍक्च्युली एप्सिलॉनच्या साईडला घेतलं पाहिजे.
एक मिनिट थांबा.
सर कारण एप्सिलॉन अपॉन 2 मॉड असणार.
हो सर, म्हणजे एप्सिलॉनच्या साईडला ते घेतलं ना तर मग वेगळं आहे.
चुकलं मला. बरोबर आहे, तुम्ही म्हणताय ते. हा जो कोइफिशियंट आहे तो आपल्याला छोटा करायचा आहे की मोठा करायचा आहे, ते बोलताना माझं चुकलं. Mistake. Okay, before arriving at the answer, let us say this is what is my delta eventually. This is what is going to be my delta, and this is what is going to be the constant, and I want to call this as epsilon. बरोबर आहे. Therefore delta should be equal to epsilon into 5x square plus 1 upon 5x square plus 6x plus 12. Okay, are you there? This is what is calculation. We want to consider this quantity to be less than epsilon. We want to show that whatever we have considered should be less than epsilon eventually. So we simplify, and here we want to show that this quantity is less than epsilon, this quantity is less than epsilon, and out of which this quantity is delta. So delta into this quantity should be less than epsilon. Therefore delta should be less than epsilon into this quantity. Now epsilon into this quantity, and if we want to be safe, we should put bigger number in the denominator and smaller number in the numerator. Therefore this comes out to be, this is estimation, this comes out to be epsilon into, किती येतात आता इथे स्मॉलर नंबर टाकला की 10, 10 and
10 by 75.
10 by
75.
75, which is equal to epsilon into 2 by 25. So 2 by 25. Okay, so now choose
15.
2 by 15. Sorry, एक मिनिट, काहीतरी घोळ मारताय माझं हे. Anyway, 2 by 15. Therefore choose delta is equal to minimum of 1 comma 2 epsilon by 15. And then if we do this, we should write this complete and then it should be less than epsilon. Hence, by definition of limit, you get limit x tends to 2, x cube minus 4 upon x square plus 1 is equal to 4 by. So have you understood the estimation tool that we are using? Now, if you choose delta is equal to say 2 here, if you choose delta is equal to 2 here, instead of 1 you use 2, then this number will change. This number will become 2, but the proof will be complete. Now this is academic proof that we are writing. We want to have a proof why is this limit true, and therefore this is for purely academic purpose. Now if I change delta from 1 to 2, I have nothing to lose right now. But when it comes to actual physical application, choosing delta from 1 to 2 might be very, very expensive. I might not afford to do that. In fact, I might require to still lessen this particular delta. I might have to do it 0.5. Okay, so that ring example is very, very important. We arrived at 1 minute. If we go for less than 1 minute, we were not achieving dimensions. And if we go more than 1 minute, our productivity was at loss. Therefore, that is optimization. What should be the timing of the ring? How many minutes should it stay in the mold so that we achieve productivity as well as we achieve dimensions? And that is what was trial and error there, because data was dependent on many, many variables, and hence those trials must be conducted. And finally, we arrived at, with no mathematical modeling, we arrived at based on our experience. We arrived at based on our trial. See, if we would have got the modeling done, if we would have got the mathematical expressions done, then it could have been like, see, 55 seconds or 57 seconds. The answer could have been like that, because these iterations I can always perform if I have a function with me. But because we do not have any function, we go by trial and error. And see, waiting for 1 minute doesn't make any difference in productivity, as well as we are getting the dimensions. Therefore, we finalized 1 minute. It is easy to control also. That is why 1 minute. But as far as this delta is equal to 1 is concerned, why? I mean, you take 2, no problem. You take 100, no problem. Because academically, this proof will be complete, because getting rid of this particular multiplier, which is otherwise a function of x. You cannot predict what is the value of this for different x, and we want to have this value to be very, very safe. And 10 upon 75 is going to be safe value for delta is equal to 1. So either you choose delta is equal to 1 or epsilon into 17 by 70, 10 by 75. Whichever is minimum you choose and go ahead, you will get the desired epsilon. That is what is the idea of writing these kind of proofs. Tell me if you have any doubt.